object is placed at the focus point. Suppose this arrow represents the object as in all cases, and we have moved this object from infinity to now at focus point, which is our fifth case. The very first case was the object placed at infinity. Then the second case was the object placed beyond C. Third case was object placed at C. Fourth case was object placed between C and F, that is center of curvature and focus point. So the fifth case, as we move towards pole, is when the object is placed at focus point. Now let us see what are the four types of results when the object is placed at focus point. The very first two results, that is position of the image and whether the image is real or virtual, we get it by mirror formula, as we have seen in the previous cases. Let us see what do we get in this particular case. Now, since the object is placed at focus point, and for all theoretical questions we have assumed that for easier calculation r to be minus 10 centimeter. Why minus 10? Because this position of center of curvature is lying on negative x-axis. So this point is minus 10, this point is minus 5 focus point. So since the object is placed at the focus point, then automatically the distance of object from pole becomes equal to focal length, that is minus 5 centimeters. Correct? Now let us check the two results from the very first mirror formula. That is 1 by V plus 1 by U is equal to 1 by F. Now if we substitute these values of U and F in place of U and F in the equation, then the equation becomes 1 by V plus 1 by minus 5 is equal to 1 by minus 5, which we can rewrite it as 1 by V minus 1 by 5 is equal to minus 1 by 5. Now, as in all calculation, if we take this negative term on the left hand side to the right hand side, this equation becomes 1 by V is equal to 1 by 5 minus 1 by 5. Now, since the same term is being subtracted, that is 1 by 5 minus 1 by 5, same term minus same term, it will result into 0. 1 by 5 minus 1 by 5 will result into 0. So this will become 0. It means since 1 by V is 0, it means V is equal to 1 by 0, or we can write V is equal to infinity. Correct? If you remember, any number upon infinity is 0, it means any number upon 0 will be infinity. And that is what coming out to be here, V is equal to infinity. Correct? Now, if we try to draw results from this calculation, what do we get? What do we get? This infinity, this is positive infinity. Correct? This infinity is actually lying on positive x-axis, correct? At a very far distance. At a very far distance. It means the first result, which we can write it as image formed at infinity or infinite distance from pole. Correct? The very first result we can write it as image is being formed at a very infinite distance, very long distance from the pole. Second thing, since this is the mirror and image is being formed behind the mirror, this is positive infinity. The image is formed behind the mirror. If the image has been formed in front of the, suppose I am the image and I have been formed in front of the mirror, then this image is real. But since the image is being formed behind the mirror, so the image should be virtual. So second result, what we can write here is the image is virtual. Correct? So we have found the two results that is position of image and whether the image is real or virtual. In this case, the image is coming out to be virtual. Now if we use the magnification formula and try to find whether the image is magnified, diminished or equal to height of object, and the second result is whether the image is erect or inverted. Let us see what it comes out to be. H2 by H1, where H2 is what? Height of image, H1 is what? Height of object, is equal to minus V by U in the magnification formula. So if we substitute the values of V, which we have calculated by taking U as minus 5 in this particular case, when the object is placed at focus point, we can write this equation as minus infinity upon minus 5. Correct? Now this minus gets cancelled and H2 upon H1 is equal to infinity upon 5. Now what is infinity upon 5? If you divide a very large number with a very small number, what will be the result? It will be a very large number itself. Correct? So the result should be infinity itself. Correct? I will explain you. If you suppose take out a bucket of water from ocean and if you say I have emptied ocean, will it be valid? Will it make sense? No. The answer will be it is still ocean, the volume has very negligible effect. So if you divide a very huge number, infinity means very huge number, with a small number, the result will be the same huge number. So infinity upon 5 should also be infinity. It means if I take H1 on the right hand side, H2 will become H2 is equal to infinite times H1. Infinite times H1. Okay. Now let us see what are the two results from this calculation. Of magnification formula. Now if you see here, this H2 is a very large number into height of object. Now if I say, if I have 100 rupees, the same example, if I say if I have 100 rupees and you have infinite times what money I have, the result will be, the output will be you are having infinite amount of money. Correct? So the answer should also be infinite here. It means the very first result we can write is image is highly magnified. Highly magnified means object has a considerable height, but image has a very very high value of height. It is highly magnified. The second result which we can write is, since this value is coming out to be positive and not negative. If you recall, we have seen in different cases before also, if the value of height of image comes out to be positive, it is erect. If it comes out to be negative, it is inverted. Why? Because height we calculate on y-axis, and if it is coming out to be negative, then it should be calculated on negative y-axis. Correct? So here if we can write it as image is erect. Image is erect. So finally we have found the 4 results for this particular case when the object is placed at focus point in front of a concave mirror. Now since it is placed at focus point, and since we are doing calculations for theoretical problems, theoretical questions where no data has been given and still the question asks you describe the nature of image, position of image, whether it is real, virtual, erect, inverted, and so and so, then in that case, to make calculations easy or to understand things or to write the results rather in a very quick session of time, we will consider R as 10, minus 10 in case of concave mirror, because this point comes out on to be on negative x-axis. So R becomes minus 10, and since for small apertures focal length is half of radius, so it becomes minus 5. Correct? Now since the object is placed at focus point itself, So this point is -5, so we have taken u as -5 centimeters. Right? Now to get the first two results, that is where the image is being formed, position of image, and whether the image is real or virtual, we have used mirror formula as done in previous cases also. So I have substituted the values of u and f in this mirror formula, and finally I have got the answer as v is equal to infinity. Correct? How? When you substitute -5 and -5 both on left hand side and right hand side as the value of u and f, and this equation becomes 1 by v minus 1 by 5 is equal to -1 by 5, and as you take this negative -1 by 5 on the left hand side to right hand side, it becomes positive. So same number gets subtracted from the same number. It means 1 by 5 minus 1 by 5, because there is already -1 by 5 on the right hand side due to focal length. So it becomes 0. So 1 by v is equal to 0 implies v is equal to 1 by 0, which means v is equal to infinity. Now since v is equal to infinity, the image is being formed on positive x-axis at a very far distance, that is termed as infinite distance. So the first result we have written is image formed at infinite distance from pole. Correct? Now since the image is being formed behind the mirror, you see this shaded portion of the mirror, this part is behind the mirror. Now since image is being formed behind the mirror, the image is virtual. So this is the first case where we are getting a virtual image. In all the previous cases we have got real images. Correct? And by using the magnification formula, that is h2 by h1 is equal to minus v by u, and by substituting the values of v and u we have considered, that is the distance of object from pole, that was -5 centimeter in this case. We have calculated as infinite distance or infinity. We have substituted here, and infinity upon any number is infinity itself, like I have explained by taking the case of ocean. So h2 by h1 is equal to infinity. If h1 goes on right hand side, h2 is equal to infinite times h1, which means doesn't matter what the height of object is, the height of image will be huge, infinite. So it turns out to be infinite. So it gives us two results. The first result is image is highly magnified, and the second is image is erect. Why erect? Because it is coming out to be positive values.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
So the last case is the object is placed between focus point and pole. Correct? Now, why this is the last case? Because in front of the mirror we have 2 points, and we have divided the negative x-axis, the number line in front of the concave mirror, in different points. How different points? One is the farthest point, that is infinity. One can be just beyond C, the other can be on C, the fourth case can be between C and F, the fifth case which we have just seen, object placed at focus point. So the sixth case becomes object placed between focus point and pole. Now since the object is placed between focus point and pole, so distance of object from pole will also change. Correct? Now since this point, focus point is -5, P is origin 0, so we can take any value between -5 and 0. For convenience, we will take -2.5. Okay? Why? Because -2.5 is greater in terms of negative sign. It is greater than -5, or in terms of magnitude, it is less than 5. See, this point can be, less than minus 5, or if we talk about magnitude, but if we talk about the number with sign, this is greater than minus 5, correct? So we can take any value between 0 and 5. I have taken 2.5. Why minus 2.5? Because this is on negative x-axis. Okay. Now again, I will use mirror formula 1 by v plus 1 by u is equal to 1 by f, and check what are the two results which can be obtained. 1 by v plus 1 by u is equal to 1 by f. And like in all cases I have done, I will substitute the value of u and f in this equation. So this equation becomes 1 by v plus 1 by minus 2.5 is equal to 1 by minus 5, which can be properly written as 1 by v minus 1 by 2.5 is equal to minus 1 by 5. Now if I take this negative value on the left hand side, that is minus 1 by 2.5, on the right hand side, it will become positive. And I will write the positive term first on the right hand side and then negative term. So this equation becomes 1 by v is equal to 1 by 2.5 minus 1 by 5. Correct? Now if you remember, to solve this question, I will multiply the denominator with the numerator of first fraction and denominator of the first fraction with the numerator of the second fraction, and also multiply the two denominators with each other. So this equation becomes 1 by v is equal to 5 minus 2.5 upon 5 into 2.5. I am not writing the result of multiplication in the denominator because something might get cancelled. So this becomes 1 by v is equal to 2.5, 5 minus 2.5 is 2.5 in the numerator, upon 5 into 2.5. Now this 2.5 gets cancelled. So 1 by v is equal to 1 by 5 is equal to 1 by 5, or v is equal to 5 centimeters. So finally I have got the value of v, which is coming out to be positive this time, and it is 5 centimeter. Correct? Now let us draw conclusion or result from this calculation. It is, the first result can be written is, since this value is positive, let us locate this number on the x-axis, because we are talking about horizontal distances. V and u are supposed to talk about horizontal distances, whereas h2 and h1 are supposed to talk about vertical distances, since they are for heights and this is for distance. Now since this is 0, since this point P is 0, 5 might be somewhere here, this point. You see this yellow cross sign? This is the positive value, or this is the point at which image is supposed to be formed. So if the image is being formed on the right hand side of pole, or is being formed behind the mirror, we can say image formed behind the mirror. Now I am not writing the precise value here just because it is a theoretical question. We do not have any data, but still we have to write the result, and for the sake of convenience of calculation I have considered these values. But if I vary these values, the value of v will also vary, but every time in this particular case it will come out to be on the back side of the concave mirror, behind the mirror. Correct? So since in this case it is coming out to be behind the mirror itself, but at 5 centimeter, I am just marking the point and stating that image will be formed behind the mirror. Correct? Now since the image is being formed behind the mirror, like in all cases, if I am the image, this is the mirror, and image is being formed in front of the mirror, then the image is real. But at this time the image is formed behind the mirror, so it means the image should be virtual image. That is our second result from mirror formula. Now if I use magnification formula, that is h2 by h1 is equal to minus v by u, and I will substitute the values of v and u. V I have obtained from calculation using mirror formula. U I have assumed to be minus 2.5 centimeter because the object is placed between focus point and pole, and the focus point is minus 5, pole is 0, so it should be anything between focus point and pole. I have taken it as minus 2.5 centimeter just for the sake of convenience of calculation in theoretical questions. So after substituting these values of v and u, it becomes minus 5 upon minus 2.5. Correct? So this minus gets cancelled. 2.5 into 2 is 5. So this, if I take h1 on the right hand side, this h2 becomes 2 times h1. Correct? Now let us draw results from this calculation. Let us draw results from this calculation. See, the height of image h2 is 2 times the height of object. Then we can say the height of image is double the height of object, or in other words, the height of image or the image is magnified in comparison to object. So first result we can write is image is magnified or double of object. Correct? And second thing, since the value is coming out to be positive this time, if you see this is plus 2, not minus 2. And since the value is coming out to be positive, it means it should be erect. If the value comes out to be negative, then the image is inverted. But since the value is coming out to be positive here in this particular case, then the object is placed between focus point and pole. So we can say image is erect. Correct? So before we draw the image, let us see the calculation in this case again. The object is placed between focus point and pole. Correct? This focus point is minus 5 according to my convenience. For theoretical question, I have taken R to be minus 10. This point C as minus 10. So point F automatically becomes half of it, that is minus 5. Pole is 0, our origin where y-axis and x-axis meets. So this object should be anywhere between minus 5 and 0. I have, for the sake of convenience, I have considered it as to be minus 2.5. So I have taken u as minus 2.5 where f is minus 5. And I have substituted them in mirror formula, calculated the value of v, which is coming out to be plus 5 centimeter, which means the image is being formed behind the mirror. This yellow cross you can see, and since it is being formed behind the mirror, the image should be virtual. I have written over here virtual image. And using magnification formula, h2 comes out to be 2 times h1, positive value 2 times h1, which means image is, if object is small, image is double of it, and since the value is positive, the image should be erect. Correct? So if I have taken the length of object, the height of object as this white arrow, then the image should be double of it, roughly of this height or length. You can see this is the height of the object and this is double of the height of the object as per the result. So this was the sixth and the final case. What are the possible places where objects can be placed in front of the mirror? Why there are 6 cases? Because since we are talking about the front part of the mirror, and there are 2 points which are going to divide this negative x-axis in different intervals. So one point is very obvious when the object is placed at very far distance. The second one is just beyond C. Third is at C. Fourth is between C and F. fifth is at F, and sixth is between F and P. We have used two formula, that is mirror formula and magnification formula. Mirror formula is 1 by V plus 1 by U is equal to 1 by F, which gives us two results. The first result is position of image. The second result is whether the image is real or virtual. The second formula, magnification formula, that is H2 by H1 is equal to minus V by U. It gives two other results, that is whether the height of image is equal to height of object, whether the height is more than the object, or whether the height is less than the object, that is diminished. And the last result, the fourth result, is whether the image is erect or inverted. If the value of H2, that is the height of image, comes out to be positive, then the image is erect. If it comes out to be a negative number, or it comes out to be a negative value, then the image is inverted. Correct? I hope you understand these data, or whatever the cases we have considered. It is just for theoretical questions where we are assuming in those questions data has not been given, but still the question is asking nature of image, size of image, position of image, where it has been formed or not, real or virtual, erect or inverted, without giving any data. In that case, I suggest you can take any values you wish, but I suggest you should always go for 10 and 5, 10 for R and F is equal to 5 automatically, because for small apertures of spherical mirror, F is equal to focal length is equal to half of radius. Since all the points are coming on the left hand side, that is on negative x-axis, these values will be negative. R will be minus 10 and focal length will be minus 5, because these points are lying on negative x-axis. And using these values and what we have done and what we have seen for different 6 cases, you can easily draw these diagrams and easily get the results which you see in that tabular form. So you don't have to worry about memorizing that tabular form. Within no time, by doing all these calculations, you can learn that tabular form of different cases of position of objects placed in front of concave mirror. Now, after seeing these cases of concave mirror, let us understand why there are only few cases, very few cases, when the object is placed in front of convex mirror, and how to solve them if the questions are based on theory of convex mirror, that is data has not been given. Similarly, as we have done in concave mirror, when the data has not been given and still it asks for size of image, nature of image, where it has been formed, etc., etc. Okay, so let us understand for convex mirror now what are the different cases possible and why we need not memorize that tabular form and can solve quickly for theoretical questions. And also when in numerical questions data has been given, then also we can substitute those values and easily calculate whatever has been asked in the question.